the end of October, which will be talking about there'll be a lot of talks there about people's efforts with analysis ready data. And I'm going to be organizing some sessions on talking about the Python ecosystem with xray and Dask, and trying to figure out some standards around that for improved interoperability of Python libraries using xray.
That's awesome. Is that ARD zone?
Yeah, ard.zone.
Okay.
Yeah, so if you have any cool talks, you should submit them.
Cool. Thanks.
Okay. So today I don't really have a presentation. It's going to be a demo. I have a notebook and I'm going to go through it, and it's going to be interactive, and I hope it works. I hope I don't have this demo effect. This is all with the Microsoft Planetary Computer, which has been acting flaky as of like 10 minutes ago, of course. My server did finally start, but it's not showing any of my files, so we'll see. I might have to shut it down and restart, but let's see, let's share. Okay, so the Planetary Computer. So Microsoft has started this effort called the Microsoft Planetary Computer, for those of you who don't know, and it's part of their sustainability initiative. So it's this branch of Microsoft whose goal is ultimately to try and reduce their carbon footprint. And I believe that their goal is actually to completely remove all of their carbon footprint by 2050. So the idea is that by enabling earth science in the cloud here can help achieve that goal through through knowledge, I guess. So this is the main page of the Planetary. Well, this is the main page here. And it's got some great documentation there. You can request access. Currently, right now, I'm not quite sure how they actually accept people, or if anybody can just request access, but you should be able to request access, and once you get it, you'll have access to essentially a Jupyter hub. The documentation is really great, and most importantly is that they have a whole lot of data available that they've been working hard at ingesting. Now, the nice thing about this effort is, unlike the AWS public data sets, this is a top-down approach, and so all of the data sets are consistent in the sense that the stack records look alike and they have the same information in them, and all of the data is cloud native, rather than leaving it up to the data providers themselves to figure that out. And that can be a big help, because you don't have to worry about these differences between stack catalogs and things not being supported. And so, as you can see, there's a lot of different data sets here. There's a whole lot more down here, and they're ingesting more on a weekly basis. And there should be some announcements this week at Phosphor-G, or I think that they'll be talking. I think Thursday is like Planetary Computer session. Will they be talking about a lot of this stuff?
Matt?
Yeah.
Is it true that they're also like contributing to like PanGeoForge and using that for some of their rechunking to create these?
Yeah, so that's a great point. So yeah, not only I believe they are supporting some PanGeoForge stuff, but generally speaking, all of this work is really being done in the open. So these data sets that are being ingested are actually all in open source repositories, stack extensions, stack tools. Yeah, stack tools. So stack tools is sort of the main library, and there's stack tools packages here. And so there's a GitHub organization that has essentially every data set is its own package within this repository. And so this is great. They've also been funding PySTAC-Client, and PySTAC, and really the entire PySTAC ecosystem. And then most recently, which is really quite new, in the last couple of months, they've been funding some updates to Open Data Cube. And so I'm going to actually be demonstrating that today. So Open Data Cube was a library that was started by Geoscience Australia. And it works in a similar fashion to stackstac or intake-stac in the sense that it's going from data on disk into xrays. And so we've created, we've been working with them and creating ODC Stack, which is a loader for Stack, so that you can point Open Data Cube at a STAC API rather than the Postgres database, which it had traditionally relied on. So let's go back to the notebook here. So I was going to demonstrate just querying the STAC API. Oh yeah, I did want to look at the STAC API real quick. So this is the STAC API. So all of these data sets are in a single API. All of these child links are different data sets. And it works just like any other STAC API if you're familiar. So you can do cross-collection search. You can go to a particular collection and just search that. If we go to Aster and go to items, we can see an example of a single item. Things to point out here are that the proj extension is in use. So this enables the client to be able to know what the native projection is and the shape of the array and the geotransform of it, so that they don't actually have to hit any of the data, and the CRS as well. So first off, this first cell is just some basic. Let's see if this actually works first. Okay, so it seems to be working. So the first thing we're going to use is PySTAC-Client to open up the PySTAC, Planetary Computer API. And it doesn't actually do anything. It just opens up that landing page. We're going to grab the Sentinel-2 collection. That's what I'm going to use today. And here I'm just printing up all the assets so we can see what sorts of assets are available in this collection. We have all of the data assets as expected, and we also have all this metadata as well. I'm not going to use this metadata, but that's an important thing to point out, is that in Stack, an asset isn't just data. It could also be metadata. It could be additional information. It really could be anything that is related to that scene. It could be CalVal report or something. So now I'm interested in actually querying something. So I have an AOI here. Hopefully, okay, I did read it. Okay, great. So I have an AOI here in Northern California, and it's centered around what's known as the Bear Fire. So if you're interested in reading more about it, there was this North Complex fire in August and September of 2020. And this is like a little bit further north than Sacramento. And it burned for a month or so. And of course, it wiped out a whole lot of vegetation. So I thought it would be an interesting thing to take a look at. So what we're going to do is search for the Sentinel-2 L2A data, that's the level 2 data, with this geometry over the years of 2019 through the present. And I'm looking for low cloud cover scenes. And the limit is just saying, that's just telling PySTAC-Client to fetch 100 items at a time when it pages through. It's transparent. It's not something that matters for the user. Okay, so here I've done the search. I've found 82 items, and here's just the first 5. These are just the stack items in a data frame. And here I'm going to actually plot so we can take a look at what these footprints look like. This does this takes a little bit longer than I would expect, but it's pulling some tiles from OSM as well. So this is nice. This is using HVplot plugins for GeoPandas, and also use HVplot, which is a high-level library for using hollow views and GeoViews, and it's pretty slick. So here we have an interactive Slippy map. We can zoom in and out. The blue is our area of interest. So here we go. This is the section. I didn't actually intend for it to be on a tile boundary, but it's actually a good demonstration. It seems like every time I pick an AOI, it's always on some tile boundary. I don't know if everybody else has that same problem, but you know, it used to be kind of annoying. Well, with Open Data Cube, things are a little bit better. So now we'll go to Open Data Cube. I'm providing some additional information here with this YAML config. The goal is in the future, this won't be needed. A part of this effort was really identifying additional metadata that needed to be in the stack record so that we wouldn't have to hit the data files. And of course, as it turns out, we don't have the data type within the stack metadata record. And so other libraries have done this by usually presuming that it's just a floating point, which you could do, but that's not really ideal to have all your xrays in floating point. So here I'm just saying all my assets are 2-byte ints. And then I'm loading it into ODC. So of course, this took no time at all because it didn't actually load anything other than the metadata. We see that we have a 20,000 by 10,000 scene because if we look at an actual data variable, this is essentially 2 scenes stacked on top of one another, right? From our diagram above, because we're on that boundary. So we have the top and the bottom. It's the whole entire area. And also notice that we have 50 time points, all right? But hold on, if we go back up here, right, it says that I have 82 scenes, not 50. So why is there only 50? Well, if you take a look at these date times, you'll see this is July 13th. This one's July 13th because it's those 2 data frames. Open Data Cube takes care of that automatically and will group together scenes from the same date. So we actually have 50 unique dates, and some of those are actually multiple scenes. So we won't have to worry about that tile boundary.
Hey, Matt.
Yeah.
Sudhir has his hand up.
Oh,
hey,
yes.
Matt, quick question. So like, you said like, you can read in the YAML config files, right? So can you read in different formats to read in those config file as well, or the YAML is the one?
Yeah, so right now it's a YAML just because that's what Open Data Cube used originally. So what Open Data Cube is doing is it's going from the stack representation to its own internal metadata model that it used to use and continues to use in a database. And so it uses this YAML config. So in this first version, which will be like a 0.1 version of ODC stack, it's YAML only, but in the future, I'm thinking it would be nice if it was a JSON file that was essentially really just additional stack metadata that could get merged with the other stack metadata, or ideally it's not needed at all because all that information is present in the catalog.
Okay, thank you.
Matt, could you also say what you, well, maybe you will, but what do you mean by open in Open Data Cube? Like, what is it? What function? What's happening there as opposed to just like loading it in xray or something?
So that's what it's doing. So it's really opening up an xray. It's got all sorts of background functions for aligning the grid so that it's determining what the final grid size is based on. So here, right, I'm giving this an output CRS and a resolution. So it's parsing the metadata and it's like, okay, here's what you want for an output. And so this might, in this case, I'm using the same output CRS and I'm using the same resolution as the input. But if I was using something else, then this array would be something completely different, right? It would be a different size. It might even be a different shape depending on what that projection is.
So everything's lazy, but it's queued up everything to do all the interpolation or whatever, or warping or, okay.
Yeah.
Okay.
Yeah, exactly. And oh yeah, and there, I guess a couple other things to point out here in the stack load. So here I'm giving this measurements keyword, which is also a holdover from ODC that will change. But this is saying just open up the bands 2, 3, 4, and 8. So red, green, blue, and near IR. I'm giving it a chunk size. If I don't give it a chunk size, then it'll just open up xrays and read everything. But by giving it a chunk size, you're explicitly saying use dask. So it's going to be lazy. And then this patch URL, this is PC is Planetary Computer. So they have a Python library. And this is just necessary. All of the Planetary Computer URLs need to be signed. you currently don't need a token or anything, but they still need to be signed. So this just will automatically apply that function, this PC sign function, to all the URLs.
Hey, Matt.
Yeah.
So that chunk size has nothing to do with the chunk size in the data set, in the file. This is a chunk size that's somehow dealing with passing data to Dask.
That's right. Yeah. So these are the Dask chunks, and that's a great question. And I think that there's still some work to be done here, because you would think, right, that those, I mean, they're related. How they're related and the performance of that, I don't think anybody really knows it explicitly, how this works, because it's so dependent on the use case. But you would think that you'd want your Dask chunks to be the same as the original tile size, right? Where one Dask worker is going to read in one tile or maybe multiples of tiles, but actually fall on those boundaries. And I think in theory that you would want some alignment there. So you'd want to know what the internal tile size and make your Dask chunks the same size. However, in practice, you're talking about multiple files that may not be aligned. You might have different projections in the files. So you very quickly will not be aligned with the internal tile size unless you really had a simple case where they're all in the same projection, and they're all aligned to begin with.
And there's no chunking in the time dimension, right? Is that just implied to be one?
Yeah, so that's implied to be one, and you can see that here with the chunk. So it's 1, 2048, 2048. So you could chunk it in the time dimension, but it doesn't really make a whole lot of sense to do so because they're different files. If you had like a ZAR data set where you had chunks in the time dimension as well, then that's a different story. But in this case, really your bands and your times are a chunk of one.
Thanks.
Okay, so now next, of course, that's two scenes. We're not interested in the whole thing. So we're going to use Rio xray. Now, there is, I believe there is a function in ODC to do this as well. But I wanted to demonstrate that we have this in an xray now, right? Like this is really all that ODC is doing. And as long as it's providing the right attributes up here that provide the spatial reference, then these things are somewhat interoperable. Problem is that there's talking about before where some people, I think there's an unwritten sort of approach here which says make your CRS available, make the spatial ref available as a scalar coordinate or something like that, and that's kind of what everybody does. So that's what Rio xray is assuming, and ODC does that, and xray spatial is another library that does that. But beyond that, I think that everybody sort of makes xrays a little bit different. But in this case, we can use the Rio xray functionality of clipping. So here we have a much smaller array. If we take a look at it, because this is just our region of interest here, and of course still our 50 data points. So I'm not doing anything too complicated today here. I'm going to use this ODC algorithm to colorize, just make an RGB image. And you can see that was super quick because again, it's not doing anything. It's just reformatting and pulling out certain bands that it wants to use. And then here, I'm going to calculate NDVI. And again, instantaneous, right? We do a band difference, and then I clip that to 0 or 1, and it's not doing anything. So what we really need now is a Dask client. So I'm going to start this up. And this is using Dask Gateway. If you've used Jupyter Hub before, you know that there's this integrated Dask feature where you can start up clusters there. And you can do that, but then this connection doesn't work in Planetary Computer right now. So the preferred way is just to start up the Dask client from within the notebook. Evidently, when you start up the Dask cluster here, you can inject code into your notebook to use it, but it doesn't understand gateway tasks. So here's our dashboard. So open this up and all right, great. And I scaled it to 10 workers, but I see it looks like it only has 3 workers. Which is good, at least it has more than 0, because I was having that problem earlier. And now we want to actually compute. So I have this NDVI array and this viz array. And so I'm going to use the client persist function to actually run those calculations. And if all goes well, here we go, this will start processing. And I think that before Microsoft they had a limit of 7 workers. So I was actually trying to start up with 10 and it was limiting me to 7. Now it's limiting me to 3. So I don't know if they're like getting ready for Phosphor-G and they're wanting to clamp down some things so that they have less troubles or something, but I'm going to have to ask them about that.
Was
So
this the Matt in the beginning? Oh, sorry.
Yeah, no, go ahead, Rich.
In the beginning in Planetary Computer, you have to select some instance types, right? I assume this is the Pangeo notebook one.
Yeah.
Okay.
Yeah. So it could be that. Yeah, I had a little bit of trouble starting this one, so maybe I'm not on a larger instance that I was before. So this takes a little bit longer, but not too long, because I knew better than to try and process a whole lot of data for a demo. My goal is on Friday to pull out on using AWS is to pull out a huge Landsat slice over a couple decades. So I gotta see if I can't get that working, because that would be pretty cool.
This is nice. You have no white space at all, right? Like everything is busy for sure.
Yeah. All right. A minute and a half. So this was, let's see, 82 files, right? Or 82 scenes. And it was reading 4 of those each. So that's a significant number of files, over 300 files that it read in a minute and a half to pull out the area. And so now I will plot the visible. And here we go. Here's our image. And using HV plot, we have this time slider here. Now there is a delay between when, all right, so there's a little bit of a delay between when I do the slider. And I'm not going to go through all of these because there's 50 of them. But if I go forward a bit, it's maybe a little dark. I could have maybe scaled that a little bit better, but we see more or less the same thing. This is a whole bunch of vegetation. And if we go to 2020 in August here, you do see that there's some half scenes here just because there was for whatever reason, there was just the one scene and not the bottom scene. So if we go through to August 12th and the 27th, all right, we can start seeing, you can actually start seeing the fires themselves, and maybe you can't see it as well here, but there is some glowing fires. And then when we get to October, you see that this is a lot more brown than it used to be. It's a little hard to tell with the visual image, right? Because, I mean, you're looking and look kind of green, and now it kind of looks brown. So a better way to do that is to, of course, use the NDVI. And, oh, of course, it doesn't work. Oh, wait. There we go. All right. So this is an NDVI image. And this is a lot more interesting to look at. So here we have some really dark blue. That's really green. I guess I should have used green, but this was like default color map. And if we go forward a bit, we'll see over to June, we still see largely the same thing. And if we go to August and into September, like we did above, all right, we start actually seeing August 27th. You start seeing it lighten up. There we go. So this is now August, this is now October 6th. So this is like the tail end of the fire. It's now been going. So now we see that there's essentially like no vegetation in most of this image. It's been wiped out. And if we keep on going, even after 6 months or so, of course, it's the same thing. If you go through this, you'll see up in the northwest corner, there's some vegetation growing back after 6 months, but for the most part, this is still pretty clear. To get a better picture of it, and again, this is just kind of like a gross look at it. You want to look at this in a lot more detail, but we can look at just an average NDVI for each time point and look at that. And of course, we see a precipitous drop off here, right, over the course of the fire. And the way that we did that is we called mean, and we just gave it the dimensions X and Y. So it says over the dimensions X, Y, so that's the lat long, calculate the average, and then compute. This is actually calling Dask. I didn't actually show because it happened so quickly, but it did actually do some stuff over here. It was pretty instantaneous.
It happened so quickly because you persisted the data onto the workers, right?
Exactly. Yes. Good point. So yes, so I used the persist before. So all that data, if we look at the dashboard, we see it stores things in memory, and so it's just pulling that data. It doesn't have to go through that whole process again. So
cool.
Yeah, and then at the end, we can close the cluster, which is good practice to get into. In this case, I'm not paying for it. Microsoft is, so, but it's still good practice. Be a good citizen.
So is there anything about this notebook that is coupled to Microsoft Planetary Computer?
Yeah, so so this is running in the Planetary Computer Hub.
Right.
And so you could do the same thing outside if that's what you're asking. Like I could run this, I could take the same notebook and I could run it locally. I wouldn't be able to start up the Dask cluster.
Right.
But I could use my own Dask cluster. And I've actually been using Coiled IO quite a bit for demos, which is really slick. And I think I'll be using it on Friday for something as well. So it's a really great service that was started by Matt Rocklin. And you just essentially give it a cloud provider and a region, and it'll just spin up a Dask cluster. It's really nice, actually. Let me just show you real quick, even though this has nothing to do with Planetary Computer. Then perhaps the nicest thing about it is that you can go to your dashboard here and you can see, where's the, oh, well, I don't have any recent clusters, but if I had some recent clusters being shown, it shows the price of it. And that's something that's like often really lacking in AWS or any cloud provider, is you don't really know like what the final price is given everything that you're doing. And so here you can start up a cluster and it'll give you an hourly rate, and then you can close it down and you can see what that costs. So you could do like a subset of your data. You could process a subset of your data and really get a much better idea about what it costs. Now, of course, there is a premium using Coiled, which is about 100%. It's double the cloud cost, but I mean, I did a bunch of just development testing, and I spent dollars to do so. So if you were going to scale up something really big, you'd want to take that into consideration. But it's really easy to use. So if you just want to play around with it, that's a really great option.
Right. I think what I'm getting at is like the back, the back end is configurable, right? It could be ODC, or it could be your actual Azara store someplace or something else. Yeah. And then your front end, your front end or your interface is consistent around the fact that it's like Jupyter Notebook integrated with a Dask cluster, but you could be using Planetary Computer, you could be using Coiled, you could be using a Pangeo hub.
Yeah.
Matt Sean has another question. What are the egress costs for the ABFS data when you're using the Coiled cluster, which I assume is an AWS region? Yeah.
Yes, so you would have to pay the egress costs. So you gotta when you set up your software environment in Coiled, you gotta make sure that you give it in that environment variable that says AWS request payer, so that it knows. And then it would be the normal egress costs for the GET requests, but there shouldn't be any actual data transfer costs unless you were transferring it out of the region.
I see.
And another factor is that all this Planetary Computer is exclusively in Western Europe region, right?
Yeah.
So if you want to
Yeah.
do US West 2, it's gonna take a while. Like not, not forever, but
yes,
maybe 4 times slower or something.
Yeah, and so if you wanted to use the Planetary Computer West region,
You know why is it in, like, I feel like so many of the public data sets are in US regions.
for AWS, so they just decided for Planetary Computer to put everything in Europe. I don't recall actually the reason for that. I don't remember what.
I know for Azure, that's their lowest cost center. So like it's 2 factors. It's their lowest cost center, and it's also from a resource utilization footprint. It's their lowest carbon sink resource center as well. So
yeah, so it is important to state, like, I mean, I'll do Jupyter notebooks. Sometimes you'll run them locally, and starting up that DAS cluster next to the data, of course, is really important. But if you're running a local notebook, you also don't want to discount that is going to increase some latency as well, right? Like your DAS cluster is next to the data, but then you still got to go from the DAS cluster to your local notebook, and you're actually sending data. In this case, when you run the Jupyter Hub and it's also in that same region, then all you're sending back is the display pixels. And so that's kind of the ideal way of doing it, is to run everything in the cloud. And so that's that's one of the real powers of Jupyter Hub.
Other questions for Matt?
So you were doing rasterize equals true on those HV plots, right?
I did not do that. I had tried that, and I wasn't noticing a big performance difference. I know that's supposed to be more performant, right?
Well, I guess maybe if you only had if you only have 1,000 by 1,000, then maybe it doesn't matter. But if you had 10,000 by 10,000, then
right,
it'd be more important. You'd probably blow out your browser or something if you didn't do it.
Yeah, I've been experimenting with things. I've also been trying to do some like animation, like movies and stuff, rather than having the time scale, to mixed success on that. But so I don't know if anybody has done that using the Hollow Views animation.
Like scrubber equals true or something or whatever. Yeah. It doesn't really cache that. I think it doesn't really cache the images, right? That's sort of the problem, I guess.
Yeah, I had done it and it ran for a while and did all this stuff on Dask, and then it didn't actually display anything at the end. So that wasn't really all that useful. Yeah, so has anybody here played around with the Planetary Computer at all?
Yeah.
You have, Sean?
Yeah.
Yeah, I'm
A
kind of
little bit.
Any impressions? Like, what were your thoughts on it?
Yeah, I mean, it's pretty cool, because like Amy mentioned, it looks completely familiar, right? Like there's no weird, stuff. And to have every notebook start with a stack query is, even the modeling stuff, right? Like, is pretty darn cool. And and so, but the only little hiccup we had was that, we wanted to actually save some of our output. So, we had to go get an Azure account so we could get some blob storage so we could store our stuff somewhere, because they don't have much. It's like 100 gigabytes. I don't know what it is, but
yeah, the local storage. Yeah.
So we got some blob storage in Western Europe.
Yeah, and evidently it's also limited too. And I mean, in terms of the workers that you can start up and the instance sizes, you're not going to go here and get free processing to do like massive scaling. You kind of have to talk with them, I think, if you want that.
But the notebooks, like you mentioned, the notebooks are fantastic, right? Like they're they're like great tutorials for like how to do all this stuff, like,
Yeah.
and then they've got machine learning ones, right? That like do all this, starts with a stack query, process a whole bunch of imagery, and then uses PyTorch and, like the whole thing. It's like,
Yeah.
Yeah, are they going to add this to those example notebooks? Because this was kind of, I don't know if Sudhir was getting at this, but I think, yeah.
Yeah, I'll be opening. Yeah, so I know, yes, here you had asked if this was public. So this isn't yet, but this will be the notebook I'll be using at my talk at Phosphor G. And so prior to that, so this week, we'll have a repo up that will have a couple example notebooks in it, along with a Docker file for like running it locally. And then I will also take this one and I'll PR to the Planetary Computer examples. So as you know, when you can't see it here because I don't know what happened, but this is your file browser in Jupyter Hub. And I do have files here, like this is one of the files, it's just not showing up. When you first start up, you'll have a Planetary Computer examples folder. And it's the repo, it's the Microsoft repo that's Planetary Computer example. So I'll be making a PR to that. And so when that's added, you would see that in your Jupyter Hub.
And don't store your notebooks there either, because they go away.
I have been, but I think.
Oh yeah, make a new folder. Make a new folder that's not in the Planetary. Anyway.
Yeah, I'm not seeing here actually like the GitHub integration. So potentially you could integrate a GitHub plugin with your Jupyter Lab, right? So that way you have source control over your notebooks.
Yeah, so I don't know what other people do, but what I do is
just use that.
You have terminal access here.
Yeah, it's kind of easier anyway.
Yeah, so I just do that. So I added an SSH key and then I just clone my repo and then I just use Git here. But yeah, I don't know if there's a better way to do it or not, but that seems to have worked. And I've trusted that my changes, I haven't been committing my changes right away, but given now that it's been acting flaky, I think I'm gonna push my changes up before I lose them.
How do you do environment? How do you set environment variables here? Do you know?
For what?
Well, I'm thinking like, a token like that you might need to access some data, right? Like, you don't want to put it in your notebook, obviously, but how do you set the environment? Like does it process like the profile or something? And is there a safe way to include authentication information somehow?
I don't know what the preferred. I can think of a couple different possible ways to do it. I'm not sure what the preferred way, but you essentially you have a user, right? Like this is Ubuntu, and so you could put that in a bash file or something like that that should be processed, and then it should be available in the notebook. But I don't know. What the preferred way to do it is.
Matt, do you want to? I don't know if it's appropriate now, but do you want to touch a little bit too on, because I think it's pretty relevant to some of the stuff you brought up. Maybe what the state of the ecosystem for xray stack loading is, especially for Earth observation data, because we've had some pretty wide-ranging discussions, at least around the stack issues about Rio xray and kind of what the future of being able to manage CRSs for COGS and being able to effectively load cross CRS data sets into xray and have them use a spatial index of some sort. There's a lot of open discussion about this, but this is not something that we've kind of finalized.
I'm glad you brought it up, because I was actually going to reach out to you this week, Sean, and to talk about this, because I think you actually know way more about this because you've been following the discussion. I know there was that discussion on Stackstack. But what I'd like to do, I think you missed the beginning here, because I mentioned I'm interested in running a session at ARD this year. People will be. I'd like to get Gabe, there, and maybe Alan Snow and some folks that have been doing this stuff with xrays, and either have a panel discussion or maybe a working group. to talk through some of these issues, because my understanding is that really it's kind of like everybody, it's like an informal thing. Like I could use Rio xray with this ODC generated xray just because they kind of agreed, like, okay, we'll put the CRS here, you know, as this attribute or as a coordinate. But there's other things, you know, there's other attributes that could be used, like fill value, no data value. I don't know if there's really a standard way to do that. So I think there's a whole bunch of issues, and I mean, I don't know, but I think I know people who would, you know, I think I know all the people who would have a lot of good input into that, because it would be really nice to have some sort of xray standard, you know, geospatial standard, so that you could mix and match xray algorithms between these different packages, no matter how they were constructed.
Yeah, for sure. That would be great if that's something you're going to set up. I think it'd be super valuable.
Yeah, I'll be in touch.
Yeah, I mean, I think we're trying to get some folks to do funding for, or at least fund the xray core development team to be able to open up their work on custom indexers a little bit more,
That'd be great.
Make something that's broader.
Yeah.
Hey, Matt, what is ARD?
Analysis ready data.
Oh, okay. I thought it was just some kind of a meeting.
Well, it is. There's this ARD workshop, but yeah, don't go to the workshop and ask what ARD is, because you'll get like 50 different answers. I don't know if we want to get into that here.
I thought it was a different acronym, an acronym for something had morphed into an acronym for something else.
No, yeah, analysis ready data. So yeah, any other thoughts? Yes.
No, Matt, just a quick question. So can you share some info about the ARD workshops and the timelines for those here? You can.
Yeah, so if you go to ard.zone, it'll give some more information. It's at the end of October, so it's the last week in October. There's a call for papers, and it's still open. I know it's a pretty tight timeline, but
You were saying it might be kind of like a workshop opportunity too, to have some discussions around these.
So in the past, so I mean, you know, Sean knows because he's been at them too. Last year was virtual, and then there was two. This is the fourth one, I think. So it's been called an ARD workshop, but I have found, and I think most people would agree, it's not really a workshop. It's really just a bunch of people talking about what they've done in CalVal and sensor fusion and you know, all sorts of things having to do with essentially having data that's analysis ready, that's ready to be used with other sensor modalities. And nothing, it's like there's always some great discussion, and then the workshop ends, and then like nothing happens, right? And so one year we tried to talk about some standards around describing analysis ready data, specifically like important things like standardizing what processing level means, because there's no real standard for that. And also like how to describe radiometric and geometric errors, because that's really important if you want to combine data from different sensors. And the folks at CEOS have done a whole lot of this. And there's this thing called Card4L, and we do have a stack extension for Card4L to describe some of this stuff. But it's a little awkward. That whole Card4L isn't really a spec. It's more of kind of like best practices. And so I think a better job needs to be done at really capturing what goes in, what metadata needs to be captured for analysis ready data sets, and incorporate that as a stack extension that follows the tenets of stack, in that it's meant for a user and not meant for the data provider, which is Card4L is pretty, there's a whole lot of information there, and it's not really meant to be human readable. So anyway, to answer your question, I don't think I answered your question, but the question was about ARD. So yeah, my hope this year is to have more interactivity and some sessions So we'll have regular sessions where people will be giving presentations, but then I'd like to have some working groups or small group discussions about some of these things and see if we can't get some stuff written down.
Yeah, and I think one of the other thoughts I had about this is ESIP could be a good community to also broadcast this out to, because depending on what areas you guys are talking about, I feel like having some of that science expertise, like you're talking about radiometric error, having that included in these ARD discussions would be really important. Otherwise, it's hard to actually define what a useful ARD would be, right?
Yeah, for sure. Exactly. Yeah.
All right, Rich, you just posted NASA TV Live. Are we all supposed to go watch now? You're on mute.
Well, no, it's 12 minutes to the launch, I think.
Okay.
Right?
Yeah. Yeah, we're just about at time. Are there any other closing questions or thoughts from the group?
Super cool, man. You know, it's cool to have all these cool talks happening here on this cluster.
I'm really excited to have the notebook posted on the Planetary Computer. I'll wait for that because we have a place for case studies in the Cloud Computing Cluster web page, and we can just link. I think we'll just link to all those examples.
Okay, great.
Cool.
Hey, Matt, if we have time, this is Micah. I just had a basic question about about your notebook. Like, what are the unique parts to Planetary Computer? I mean, obviously they have the data. Is it that they offer a STAC catalog and the Jupyter Hub environment?
Yeah, that's pretty much it. I mean, you could take this whole thing and use it on AWS for the most part by pointing it or using it locally. The differences would be in just changing the API here, the URL, and there's the signing that Planetary Computer does here that you wouldn't have to do. And that's pretty much it, with the exception of the DAS cluster. So when you down here, there's a bunch of different options that you could do here. You could start a local DAS cluster on your computer, which is fine for development purposes. I wouldn't recommend it for doing anything because you're still transferring the data locally. But you can use DAS Gateway on AWS. You can use coiled. There's really a variety of options there. But other than
basically the STAC API is the critical part of the workflow.
Yeah, it is. And the DAS cluster is important. And I guess I should add too, you can't just start up any old DAS cluster. Like you need the software environment on that DAS cluster needs to match what you're running in your notebook. With coil, and this can be kind of tricky if you aren't just wanting to replicate the entire environment. Like if you want to just try and pick and choose, and so it's easy to get mismatches of software versions and stuff. So, but once you have it set up, it works great. So I do have a coiled environment set up that has open data cube in it and everything. And I don't know if those are public by default, but by the end of the week, I'll be figuring that out, because there'll be another notebook that I'll have for using the new Landsat API on AWS, and I'll use coiled.
Cool.
Yeah. Thanks. That's helpful.
I will say we need to close, but I will plug the next session. We'll probably also have another presentation by another member of the Planetary Computer group. So be on the Planetary Computer group. So be on the lookout for that. And I'll see everybody later this week or in October.
Yeah, great. Thanks.